Hi, and welcome back to PySimpleGUI 2020, Part 3, your first window. This is going to be the big lesson for you. We're going to cover all that you need to know to make a window with PySimpleGUI and execute it, the whole thing. So of all of the lessons being presented here as part of the 2020 series, this is the one that will teach you pretty much everything you need. So let's get going. Two concepts here to know about PySimpleGUI windows, and those are design patterns. There are two design patterns that we will follow. One is called a one-shot window, and that is a window that's read once and then you close it and move on. The other is a persistent window. These persist, they hang around, you interact with them, and then you close them. The difference, the big difference, is that one-shot windows don't have event loops. The anatomy of a PySimpleGUI program is always 5 sections. The event loop we said may be missing, but otherwise it's always 5 sections. And those sections are the import statement. We've already said from coding conventions that it's usually from some PySimpleGUI port as SG, because from that point on, your code can be coming from Qt, or it can be WX or web. It doesn't matter. It's SG text will be a text element, and it's the import that changes where you get it from. In theory, changing the import is all that's required to move from one port to another. In practice, it's a little more subtle than that, but that's the idea. I don't think we've talked about the ports. There are 4 of them at the moment. PySimpleGUI is the Tkinter port. It is what I would call complete. It has all the features. New features that are being added are enhancements. PySimpleGUI Qt is the PySide 2 port. It used to support PyQt 5 as well, but no longer supports that. PySide 2 only. It is almost feature complete. One of the main features it implements is the system tray. That's true also for PySimpleGUI WX, the WX Python port. And then there's web, which is the REMI port. The last 2, REMI and WX Python, are the least far along. I would say WX Python is the absolute least. It was done mostly to get the system tray support. You can get that from Qt as well. And there is even a Tkinter version that we will talk about later. Never, ever, 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 ever do from PySimpleGUI import star. You see this with Tkinter programs. Someone long ago made a tutorial where they did that, and now it's propagated everywhere. It immediately exposes you as a beginner. There are so many problems with doing this. It will automatically delete your Py file if you do that with PySimpleGUI when it detects it. So don't do it. That's a joke. It will not delete your file. But I won't answer your question if you've posted code that shows import star. You've been warned. Just don't do it. The layout. This is where the magic is with PySimpleGUI. So it defines the look of your window. And one of the things that's really cool about it is that it is visual code. So if we look over here at this example, the layout has elements in it, And you can sort of see, so let me talk about what the format of this thing is. It's a list of lists where each row is a list. This last row is the only list that has 2 items in it, which is there are 2 buttons. And each list represents a row in your GUI window. And I'll go into that in just a moment. But understand that what you're seeing is the window. So you can expect when we run this that there'll be a row that has text, a row that has an input field, and 2 buttons at the bottom. It's part of the reason why a designer isn't quite so important for PySimpleGUI, because the code itself sort of becomes a designer. You can visualize, looking at the code, what your window is going to look like. And that's just not possible with the other GUI frameworks. They don't work like that. Having it be lists of lists also means that we can build or compute layouts, which we will do later on. It's just pure magic. It's the only way I can put it. So as I mentioned, each row is an element. When I say elements, I think I've talked about this before. It's what other GUI frameworks call widgets. I don't call them widgets so that it doesn't get confused with a tkinter widget. You understand immediately that you're talking about not tkinter, but you're talking about PySimpleGUI when you talk about a text element. They all map to the underlying framework. Text is a label. Input is, what are they called? I think it's called an entry, something like that. What I call a spin is a spin box. Tkinter WXPython is called a spin button. It's QSpin and Qt, and Remy calls it a spin box, but I call it just spin. So, here's the visual representation I was talking about. So you can see this layout looks sort of like this window. And so it makes a designer not as needed, but there is a designer if you need one. And here's our layout designer. The first thing you're going to want to do is launch the designer. And you can use pencil or pen. I like pencil so that we can erase. In case you haven't noticed, this designer is pencil and paper. There is a Qt designer that has been written. I didn't write it, but you can research it if you're into it. But let's go through how to design your window. Basically, that's what this is all about. The first thing you want to do is sketch your window. And forget PySimpleGUI for a moment and just talk about GUIs. You want to sketch out what your layout looks like. Determine all the things that are inputs and all the things that are outputs, and how you want to lay those out for the user. So whether it's PySimpleGUI or tkinter, do this for all windows. So sketch your window. We're going to put it, we already mentioned, as rows. So step 3, we take our window and we've made 3 rows out of it. In fact, you see that there's 3 rows in this layout. So row 1 has elements on it. Row 2 does too. If we label them, row 1 has a text element. Row 2 has an input element. Row 3 has a button. This example over here has 2 buttons. So once you figure out what your layout is on paper, you can write the code, and then you can add it as section 2 of your program. So that's how you make a layout and kind of what they're all about. The elements, this is the tkinter list. As you can see, there are a lot of elements. I don't want to go through what they all are here. that's for another section or something, but they all map to something, and the only elements under tkinter that aren't represented are some of the TTK widgets, especially if they have a TK version. The TTK stuff is just, it's a pain to style it, so it's better to stick with just the TK versions, which is what is provided. An exception to that is buttons. There's a bug with Macs where a normal TK button won't allow you to set the color to anything but, I think, white, or else the text matches the color so it doesn't appear. So I had to write a TTK button specifically for the Mac. You can use it for Windows too. It's missing a couple of features like button images, but at least Mac users can now have buttons in their Windows. Each element, as we had discussed before, has a lot of parameters. So when we pull up a text element and we look at all these parameters, there's just a lot of them. And some of them are common across elements. And a few of those are this list here. The size, it's a tuple. This is in characters and rows. So with a text element, it will generally auto size, but let's say it's an output type of element and you want to reserve 20 characters, then you would say here size equals 20, 1. And that will give you 20 characters in your text element. A key we will get into more with events, but know that all elements have keys. It is like its name in a way. It's what you will use to identify that element. You could think of it as a key like in a dictionary. They need to be unique. If you don't assign one, one will be assigned for you. For buttons, the text on the button becomes the key. So here, this button with an OK has a key of OK. Padding is how much space to leave around the element. You can specify a tuple with 2 parameters, int. This is in pixels, and what this is the amount of pixels on the left and right and top and bottom, right? So it's the padding that will be used so that things aren't all smushed together. So let me show you what smushed together looks like. This is a launcher that I use. This has pad of 0, 0 for buttons, so there is no padding. If you were to put a pad, it would put something on the left and the right and something on the top and bottom. I think the default is 5, 3, I'm not sure. You can further break down pads beyond a simple left, right, top, bottom, and make it specific, where you can say left, left, right, top, and bottom as tuples within tuples, if that makes sense. So you can say, here, let's write it. Pad equals, and you could say like 5, 5, and that would be 5 pixels on the left and right, 5 pixels above and below. Let's say you wanted 10 pixels on the left, 5 pixels on the right, and then 5 pixels above and below. That's what it would look like. If you wanted 5 pixels on the left and 50 pixels on the right, then it would look like that. You can break it up. So there's a lot of combinations in how you can do the padding. It's discussed quite a bit in the documentation. Colors, for each element, there's different types of colors. For a text element, there's the background color that the text is on. There's the text color itself. In the documentation, there's a discussion about how to specify colors. You can use the name of a color, which there's a published list of what those are for Tkinter. There's also something similar for Qt. You can specify a string that has RGB values. Enable events is a bool, and what that does is it will generate an event if the user interacts with that element in some fashion, and that will change on a per element basis. For text, if you enable the event, it means if someone clicks that text, then it will generate an event. If it's an input text element, then when someone types a character, it will get an event. Buttons automatically have events enabled, which it's when someone clicks a button. Sliders, when you can enable events so that when someone moves the slider, then you will get an event. Visibility determines whether or not it will show up in your layout. So let me run this just so we see kind of what's going on with this. And notice the layout here. In particular, there's a bunch of space below my layout, and that's because we said on the top put 5, on the bottom put 50. So check that out. Let's see, what was I going through? The visibility. So if we want to exit out of this at the end, sorry. If we don't want the input to show up, I can say visible is false. When I run this, you will see that there now is no longer an input element. You can make it visible later. The problem with Tkinter is that it will move the element when you make it visible again to the bottom of whatever kind of container it was in. So for a window, it will move it to the bottom of the window. A trick to fix that is to put the thing that you're making invisible into a column, so that when you make it visible again and it goes back into the column, it will be the only thing that was in the column, so it will return to its normal spot in a way. This is discussed at length, I think, in the documentation, and maybe the cookbook. I'm not sure. Another place that visibility is used for inputs in particular is for having button targets. There are some buttons that fill in information in your window. You can make the input invisible so that it's filled in, it's part of the window, but the user doesn't see it. I'll show you how to do that a little bit later. You can make them visible again by calling the update method, which we will talk about later. All right, so that's it for visibility. Tooltips, each of the elements, you can have tooltips. So here, tooltip is input stuff here. So when I run this and you hover over that, you will see a nice little tooltip. You can set it for the, I think for the window as well. There's like a tool tip, maybe not. No, there's not for the window level. Sorry, I'm thinking right click menu. So also there's metadata as a parameter, and you can access that metadata later by looking up the element and accessing .metadata. So here I can say metadata is 1, 2, 3. If I look up that element and I examine the metadata member variable, it will have that value. So it's a way for you to carry around information about an element in the element itself, rather than you carrying it around in a variable of some sort. Right-click menus are part of tkinter. We will talk about that later. They are also available in at the window level, which will make it work across the entire window. And there's several things like that, where if you set it at the window level, it uses it for all things. Let's talk about fonts. That I think I skipped that. So if we said font, which comes in 2 formats, let's say it's Courier 14, and I did it at the window level here, so all of the fonts are now Courier. If I change that so that only this text element up here uses it, better to do that, then only that element will have the font change. So window level things supersede all or set a default for all the elements in the window. If you set something in the window and then you set something on the element will override whatever default the window has set up. Hope that made sense. We talked earlier about your IDE and how it is your superpower. Use Control-P to quickly get a list of all of the different options, and Control-Q as well to get the docstring information. It works not just for PySimpleGUI, but it works for all of Python. So use your IDE's superpower. If you don't have an IDE and you're looking for information about these calls, then you will find at the bottom of the documentation, the online documentation at PySimpleGUI.org, all of the call signatures. So it has not only the parameters for creating the element, but it has a list of all of the methods that are available for the element, as well as the parameters. In fact, let's go take a look at that documentation, just because it is so awesome. And you are such a good developer that I know that you're going to use this documentation, especially before you submit an issue. If you go down at the bottom using this handy table of contents, you'll see the element and function call reference. This has all of the functions that you can call, and it's got the elements. So if I wanted to look up button and what it does, it has all the parameters. It has them described in excruciating detail. It also has all of the methods that you can call. I mentioned PEP8 bindings. So here's an example of PEP8 bindings at work. This getText is a method. PEP8 says methods are supposed to be lowercase and look like this. So you will find that there is a PEP8 version. The original 1.0 version of PySimpleGUI was not PEP8 compliant with those function calls, and so at one point along the way, a complete rebinding of all of the methods happened so that there is lowercase versions, and they're all PEP8 compliant now as a result. So if you have questions and you don't see it in your IDE, or you're not using an IDE, then come here to PySimpleGUI.org and you will get all of your questions answered. Okay, let's keep moving on. Window creation, step 3. So we talked about 5 sections. We're through the first 2. We're at the window creation. So one thing that you'll notice is that I don't specify every single named parameter. The first parameter of window is the title. The second one is the layout. You don't need to say layout equals. I promise that I am not going to change the order of those parameters. Okay, so for important methods like this, I'm going to leave them like they are, so that it's very simple. You shouldn't have to specify every parameter, and it's rare that I would change the order of something. So here's where you create your window, is by creating a window object. Just like elements, there are tons of options. Way too many to discuss here. Just understand that here's the list. In fact, some parameters configure elements. We talked about that before, like font. Now let's get into reading windows and what that means. It's covered down with the event loop, but I wanted to pull it out separate. This is another critical difference between PySimpleGUI and the other frameworks. When you call window.read, you're given back 2 values. You're given the event that caused the read to return, and you're given a values dictionary. If your window doesn't have any keys, then it'll be a list, but put keys in your windows. All of that's explained. The list stuff is explained in the documentation if you want to know about that, but assume that it's a dictionary. So you call window read, you get an event like OK. The guy pressed an OK button. The values contains, it's a dictionary with all of the values of the window. So in this case, there's one input field, and it will be part of this values dictionary that comes back. So you read it, and instead of going out and asking each widget like you would to enter what the value is, you're already provided with all values for the window. So in this example, we have a key that's input, and guess what? If I say print values sub with our key input, then it's going to print that whatever we have input. So let's run this, and if I say test here, it prints test. Most of my test programs, by the way, you will notice that after the read there's a print event values. just always add that to your code for a while, because it will give you a snapshot of what's going on. If I say test and I click OK, what's printed is the event, which in this case is the OK button that was pressed, and then you see a dictionary, and it's got the key, which is our elements key, and it's got the value, which in this case was test, and it's just a great way to debug. You know, if I was to add another one of these and say input 1, and let's run that, and what's going to happen, I have 1, 2, 3, 4, 5, 6, I do OK. Now my dictionary has 2 keys, and it gives me the values for them. I don't have to go query anything to get the values. It's all in one big dictionary. This is the way GUIs were meant to work. You know, just my opinion, sorry. Another thing you will see in pretty much every PySimpleGUI program is shortly after the read, like right afterwards, there's a check to see if event is none, or in this case cancel. So sometimes you'll see if event is none, if there is no cancel button, then it would be a break. And none is what is returned if someone clicks the X button. So if I do this, then what you'll see printed is none as the event, and that will kick us out of our event loop. It's important to always check for none and some other values. If there's a cancel or an exit button, give your users a way out of your program. If you don't, then it's possible for them to close the window with the X, and your code continues to run in the background, chewing up CPU time when it shouldn't be. You know, you're supposed to exit when someone closes a window. So always put a check for none, or an exit or cancel or whatever button that you're using there. So let's take a look here. We talked about how this is the thing that really differentiates things. Reads block until events happen. So you call read, it sits there, it waits. There are asynchronous versions that don't do that. We'll talk about that later. We talked about the values dictionary, keys, all of that stuff. I don't think there's anything else on this. Oh, the window is shown to the user the first time that it's read, and there's an exception to that, and that is if you finalize a window, and I'll talk about that in a little bit. That's another time that the window is created. So just understand that calling window or creating your window doesn't actually put it on the screen. It sets things up so that whenever you do call read, then an actual tkinter window is built and shown. One mistake that early programmers do, just because they're in the habit of doing it, is calling get methods. So here you would call like a get method for this input, whatever. Don't do that, because the values dictionary, you're given what those values are already. You don't need to call get in order to get those values. Okay, Oneshot is one of the 2 design patterns. These types of windows do not have event loops, because as you can see here in this event loop, you keep doing it until something breaks you out of it, like the none or a cancel. And the cool thing about one-shot windows is that they can be done in one line of code. They're really cool. You'll see. The GUI front end we did in a previous lesson was a one-shot window. It's grabbed the parameters like a folder and then close the window and move on. So let's take a look at a one-shot here. This is a one-shot window that gets your name and your favorite color, right? And at the end, it does a pop-up and shows the event and values dictionary. So I click the OK button. That was the event. The values dictionary has 2 items. They both happen to be things that I entered and input, and the combo. So you see the key color and the value green from where I chose it out of the combo box. So let's show you the one-line version of this thing. You'll notice here that it's already been partially compressed. The way I approach compressing a PySimpleGUI program, hang on, let me make this not compressed. Okay, presto, look at that, I am fast. This is a typical window now, just like you saw before. We have our layout, we create a window, we read the window, we close the window, right? So with a one-shot, you don't really need the window because you're only going to interact with it once. And you can chain calls with Python. So you can say window read, that will create the window and then call the read. So now we can say event values equals that, right? But we have a problem where the window is still open. There's a parameter on read where if you set it to true, it will close the window after the read is complete. Now, this layout we can copy. Actually, let's make it one line. Control-Shift-J with PyCharm combines lines so that you can.
The time is 1 o'clock.
You can make lines a single line like this. So we're going to take our layout, we're going to paste it in there like that. Now, line 19 is a single line of code, and when I run this program, it does the same sort of thing. I say it's me, and my color is purple, and I hit OK. Notice there's only one window open, and it's the pop-up. It still shows me that OK is what I pressed and what the values were. So these one-shots can be very powerful to add to your code. So because in a single line of code now, you can ask the user for some information, get it, and move on with your code. You don't have to do a bunch of special tkinter code. You're replacing 20 or 30 lines of tkinter code with one line of PySimpleGUI that you can drop in anywhere, and it just works. One other thing I want to show before we close this out, you see down here the single line solution. There was a note that I had to do. A lot of times people, when they see a simple window like this one, they expect to be able to hit the return key. So I type some stuff in, I choose my color, and I want to hit return, right? That's just how you expect a GUI to operate. Well, you can make that happen with PySimpleGUI by adding a parameter here to the OK button. It says bind the return key. And what that does is it makes it so that the return key will trigger that OK button. So I just clicked or hit return, and it acted like the OK button was pressed. So let's do that again. If I just hit return, then it returned that OK was pressed. The name is empty and the color is empty. But so bind return key, very handy for these little windows as well. And that could have been combined to be a single line solution with that included. And I think that's it for this lesson. Thank you for your patience in working through it. But now you've got an education of how to build a complete PySimpleGUI window and program. So the rest is up to you to fill it out with elements and have fun. Thank you for watching, and I hope to see your creations soon.